your test coming up. Need my calculator. So, first question here. A single card is drawn from a deck. Then replace. That's a big thing, replace. Okay, and a second card is drawn. What's the probability of drawing 2 red cards? Well, the first probability of drawing a red card is a half, or if you want to think about it, 26 out of 52, because there's half the cards are red. Then it's going to be replaced, so it's going to be half again, which equals 1/4. 1/4 or 25%. Okay. If it was not replaced, as my computer chugs away, it'd be a half times 25 over 52. Okay. Which would be different. Was that 25 over 104? Okay. Give an example of the following. An independent and a dependent event. Okay, well, independent would be draw a red card and flip a heads on a coin. Okay. A dependent event may be draw a king and another king without replacement. Okay? So the one depends on, this one's totally independent. Both those are independent. Red card and flipping a head is independent. We're drawing a king and then another king without replacement is dependent because it depends on you drawing a king first and then second. Okay. A student writes a multiple choice test that consists of 3 questions, each with 4 choices. What's the probability he's going to get 2 questions correct and 1 question incorrect? So, we're looking here, a correct answer is a 1 out of 4 chance. Right? So, this would be correct. Another correct answer is going to be 1 out of 4. Then, if I were to do an incorrect answer, that's going to be, there's a 3 out of 4 chance that happens. Right? So that's 3 out of 64. And 3 divided by 64 equals approximately a 5% chance of that occurring. Okay. So if P, probability of P and A is 0.2, state whether it's mutually exclusive or not mutually exclusive. Okay. Well, they are not mutually exclusive because they share 0.2. So if I draw 2 diagrams here, 0.2 is right there, which is shared. Okay. If they're not mutually exclusive, if they were mutually exclusive, sorry, the circles will be separated. Okay? So it'll be no and, right? Because nothing is shared between them. Next one. Let F represent all the face cards and E represent all the number cards. Calculate the probability of drawing a face card or a number card. Alright, so we need our OR formula. Now these are going to be mutually exclusive because number cards and face cards don't interact. Where's my formula? So probability of a face or a number equals the probability of face times the probability of a numbered. Okay, which equals, well, probability of a face card is 12 over 52. The probability of a number card is 2, 4, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9 times 4 is 36. 36 over 52, which equals, I was going to put brackets around those, I guess. 12 over 52 times 6 over 52. Sorry, that should be add in there. My mistake. That's an add. So that's going to equal 48 out of 52. Okay? That should be an add right there. Good. Each letter of the word valedictorian is placed in a hat. If one of the letters randomly drawn randomly was probably a vowel. How many total letters are there? 1, 2, 3, 4, 5, 6, 10, 11, 12, 13 total vowel. 13 total. Okay, now how many vowels do we have? 1, 2, 3, 4, 5, 6. So 6 over 13. This equals 46%. If we went back to the last question, 92%. Right. A student flips a coin, rolls a die, and draws a card from a regular deck. Most probably the heads is flipped. So that's a half. Even numbers rolled. Well, that's a half again. And a club is drawn. Well, the club is a quarter. 1 out of 4. So that's equal 1 over 16. There's a 1 in 16 chance that'll all happen. Okay. Next one, a single card is drawn from a regular deck and the card is not replaced. And a second card is drawn. Let's probably get drawing 2 queens. Well, the first pull, drawing 1 queen, is 44 over 52. And the second queen, right, is going to be 3 out of 52. Which equals, what's that? 12 over, oh, sorry, that's a 1. 51. Over 2652. Which equals about 0.4%. Okay. Alright. The probability that a student will be going camping this summer is 72%. What was the probability of the person not going camping? Okay. So the probability of camping equals 72%. So we're really looking at what's the complement of that. So that'd be 100 minus 72. What's that, 78%? No, 28%. 28%. Okay. Next up. Wow. Let me get my highlighters out here. Oh, that's a big highlighter. The AB event, the sum of dice is 8. Okay. So we're looking at these ones right here. Okay. But B be the event that on the red die is greater than the, so let's rewrite this. That's a red. Is that in the question? Make sure that's in the question. And this is green. Oh, you cannot see that green. Let's make it that green. That's green down there. Okay, the red die is greater than the green die. Okay. So for this one, oops, this is green up here. There's the green die. There's the red die. So the red die has to be greater than the green die. Okay, 1 and 1 is never going to happen. 2 and 1, this is happening here. So 2 is bigger than 1. The 3 is here and here. The 4 should be here, 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 and not there. The 5 is here, 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 and here. But the 6 is bigger than that 1, that 2, that 3, that 4, and that 5. Okay. There we go. So what's the probability of A? Well, probability of A is 1, 2, 3, 4, 5. It's 5 over 36. Probability of B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 over 36. Probability of A and B are these ones right here. So I'm going to draw that. So here, you guys can't see that. Here, here. There's only 2 that have both. So it's 2 out of 36. Good. Now if I want to reduce these fractions, what's that? 5 over 12 and 1 over 18. Now P, probably P or B. Where's my OR formula? Probabilities of A or B equals the probability of A plus the probability of B minus the probability of A and B. So that's going to equal 5 over 36 plus 5 over 12 minus 1 over 18. So it's and that leaves us with a half. Right? Do this one orange. My given formula, probability of A given B equals the probability of A and B divided by the probability of B, which equals A and B is 1 over 18 divided by probability of B as 5 over 12, which equals 2 over 15. Okay. Then here, probability of B given A equals probability of A and B divided by probability of A. Okay. remember that these two always have to be the same. This and this. Just like it was over here. So this is probability of A and B was 1 over 18 divided by 5 over 36. 2/5. What's the probability of A prime? That equals 1 minus the probability of A. So equals 1 minus the probability of A was 5 over 36. 31 over 36. And the number in A is 5. Because there's 5 items. There's 5 8s. All right. Where? So if a card is randomly drawn from a deck, it's a probability that it's a red card or a face card. Okay, so we're using the OR formula here. So probability that is red or, oops, that's an and. Or face. So if you think about this, our red cards, there's half red cards. Plus, how many face cards? Well, there's 12 over 36. We're going to minus off. There's 6 face cards that are shared between red and face cards. So there's the red king, 2 red kings, 2 red queens, 2 red jacks. So 1 over 2 plus 4 over 36 minus, so 2/3 is our final answer here. So suppose that you study and ace this test. Suppose for the probability of studying is 80%. What's probability of ace the test given you studied? Okay, so probability of aces given you studied equals the probability you ace and study divided by the probability of you studying, which equals 0.75 divided by 0.8. 0.75 divided by 0.8. So it's a 0.94 or 94% chance your lace. A bag contains 3 white marbles and 5 red marbles. Was probably selecting exactly 1 white marble with no replacements when 2 marbles are drawn. Okay, so we need 1 white marble. That's 3 over 8. They're going to times this by 5 over 7. So that's how to get a red marble on our second one. Okay, so I'm doing combination of events here. 3 over 8, oops. 3 over 8 times 5 over 7 equals 15 over 56. Now you could say, what would happen if I pulled the white marble, the red marble first? So 5 over 8 times 3 over 7, okay, is going to give me the exact same number. So it doesn't matter realistically what ball you're going to pull first. I guess 15 over 7 also equals about 27%. Probability Cathcart watching soccer during class is 80%. So let's write down here. Probability of watching soccer is 0.8. While the probability of him watching soccer and finishing homework is 70%. So probability of watching and homework goes 0.7. While the probability of watching soccer or finishing his homework is 75%. So probability of watching soccer or homework is 0.75. What's the probability he'll finish his homework? Okay. So the big thing here is we're going to use our OR formula. So OR formula is probability of watching or homework, 0.75. Oops. Erase that. Times the probability equals probability of watching soccer plus the probability of doing his homework minus the probability of watching and homework. So we plug in our numbers here. And is, where's my and? 0.7. It's probably watching soccer is 0.8. And we don't know this part. But we know this part over here is 0.75. So I could put these two together, get 0.1 plus the probability of homework equals 0.75. Then move that over. 0.1 plus 0.75 equals the probability of homework, which equals 0. Should be a minus. Oh, I messed up here. It's racist, I wrote it backwards. This should be 0.75 minus 0.1, which equals 0.65. Okay. So that is our answer there, or 15%. I pulled these 4 questions off of another test just to give you a little more review on it. Okay, Demi, Maddie, and Laura are all members of the St. James soccer team. Team has 18 players on it. What's the probability they'll be named captain, co-captain, and water girl? Okay, so this here is a permutation question. So the way we want it, we want these 3 to be named like this. So I have 3 options, these 3 being the options. And I want them all named, where in total we have 18 options for 3 spots. Okay, so 3p3 divided by 18p3 equals 0.0012 or 0.1% chance. Right. The probability of me asking a question during class is 80%. Okay. The probability that her asking a question and asking for candy is the probability of the question and candy is 0.7. The probability of her asking a question or candy, probability of a question or candy is 0.95. What's the probability of her candy? Alright, so this is just like the question we just did. So let's use our OR formula. So probability of question or candy is 0.95, which equals the probability of a question minus the probability of candy, oh sorry, that's a plus, then minus probability of question or candy. If you erase this, let's put all next to each other. So this is 0.7 equals 0.8 plus the probability of just candy minus or 0.95. So 0.7 equals, put these two together, I'm going to get negative 0.15 plus probability of candy. Move it over, it becomes a plus, 0.7 plus 0.15 equals probability of candy. Finally, the probability of candy equals 0.85, 85%. Okay, Mr. O goes to Zares. First goal. Probably of him getting a chocolate milk is 23%. Okay. Probably chocolate milk equals 0.23. Probably getting a pizza bun given he got chocolate milk. Okay. Probability he got a pizza bun given he got a chocolate milk is 0.4. What's the probability he gets a pizza bun and a chocolate milk? So if we go to our and formula, right? We're looking at the probability of pizza bun and chocolate milk equals the probability of chocolate milk times the probability of a pizza bun given you got a chocolate milk, which is 0.23 times 0.4 equals about 9%. 0.092 or 9%. Right, last one here. You and two friends are hoping to get on the prom committee. There are 12 people plus you and your friends applying for 5 spots, so 15 total people. What is the probability that all 3 of you will be on the committee? Okay. So let's put you on the committee. That's going to be 3 choose 3 times 2 choose 13 divided by all options will be 15 choose 5. So 3 choose 3 is getting you all on the committee. And 2, oops, that should be. What happened there? I erased something all. Right, let's do this over again. So 3 choose 3 is getting you on the committee times 13 choose 2. That's the last 2 people on the committee. And all the options are 15 choose 5. 3 2 choose times 13 choose 2 equals divided by 15 0.026 or 3% approximately. Only one person makes the committee. Okay, this one. So only one person makes the committee. So it's 3 of us. One person is going to make the committee. Then of the rest of the people, 13 left, we're going to have 4 spots in the committee divided by all the options. 15 choose 5. 3 choose 1 times 13 choose 4 divided by 15 choose 5. Okay, so that equals 0.71 or 71%. And lastly, 2 or less. Well, that's going to be 100% minus all 3. So whatever the probability is for all 3, everything else is going to be 2 or less. So it's 100 minus 100 minus 3%, which equals is a 97% that 2 or less of you will make it onto the committee. Okay, hopefully that helped, and have a great day. I'll be in my room at lunch if you're really stuck.